Welcome to day 11 of our low-level design course. Today's topic is focused on two important creational design patterns, the factory pattern and the abstract factory pattern. These patterns are pivotal in managing object creation in a flexible, scalable, and maintainable way. Let's dive into understanding both patterns and how they can help us in our system design. By the end of day 11, you will be able to understand the factory and abstract factory design patterns. You will learn how they simplify object creation, making our system more flexible and easier to maintain. We will also explore why, when, and why to use these patterns, and you will gain practical experience in implementing them to solve real world design problems. Today, we will focus on two creational design patterns, the factory pattern and the abstract factory pattern. These patterns help manage object creation while keeping the system flexible and scalable. The factory pattern is used when we need to create objects of different types, and the abstract factory pattern is used when we need to create families of related objects. Let's start with the factory pattern. This pattern provides a way to delegate object creation to subclasses while keeping the object creation details hidden from the client. The factory pattern is used when we need to create objects based on input or conditions but want to hide the instantiation logic. For example, a document creation system can create different document types such as text document or spreadsheets without exposing the class details. The structure of the factory pattern involves several key components. First, there's a product interface, which defines the common behavior for all product types. Next, we have concrete products, which are the actual product classes that implement the product interface. The creator class declares the factory method, while the concrete creator classes implement this method to return a specific type of product. In our document creation system, the first component is the product interface. This interface named document defines the common behavior for all document types. For example, it may include a method like create that all document types should implement. By using this interface, we ensure that all types of documents share a common contract. Next, we define the concrete products. These are specific types of documents such as text document and spreadsheet. Each of these classes implements the document interface, providing their own implementation of the create method. The text document will contain logic for creating a text document, while the spreadsheet will handle the creation of a spreadsheet. Now we have the creator class, which declares the factory method, create document. This method does not specify which document will be created. Instead, it serves as a placeholder for the actual object creation logic. The client code will call this method without needing to know the specific type of document it will get. In the concrete creators such as text document factory and spreadsheet factory, we implement the create document method. The text document factory will return an instance of text document, while the spreadsheet factory will return a spreadsheet. This design ensures that a client code can create documents without knowing the specific class being instantiated. Let's look at the code for the document interface. The document interface declares the create method, which must be implemented by every specific document class. This ensures that each document type shares a common interface that the system can interact with all the document types uniformly. In the text document class, we implement the create method. When called, this method will output a message indicating that a top text document is being created. This demonstrates how the factory pattern allows for flexibility, enabling us to handling different types of documents with their specific creation logic. Similarly, in the spreadsheet class, the create method will output a message indicating the creation of a spreadsheet. By implementing the create method in each document type, we ensure that every document behaves consistently according to the same interface while maintaining its own creation logic. The document factory class declares the factory method create document. This class acts as a blueprint for creating documents, but it does not implement the logic for creating specific document types. It leaves that to the concrete creator class. The text document factory is a concrete creator that implements the create document method. This method returns a new instance of text document. The client code can call this method without worrying about how the text document is instantiated. Similarly, the spreadsheet factory implements the create document method and returns an instance of spreadsheet. This allows the client code to create a spreadsheet without needing to know the internal details of how it's created. The factory pattern has several benefits. It centralizes the logic for object creation, making your code easier to maintain. It also promotes loose coupling between the client code and the concrete product classes. As a result, it's easier to extend the system and add new product types without modifying the existing code. Next, let's move on to the abstract factory pattern. This pattern is used when we need to create families of related objects. These objects share a common interface, but their concrete implementations may vary. The abstract factory patterns helps to ensure that related objects are created together and are compatible with each other. For example, in a GUI system, we might need to create platform-specific components like buttons and checkboxes. The structure of the abstract factory pattern includes several key components. The abstract factory declares methods for creating families of related products. Concrete factories implement these methods to create specific families of products. Each product in the family follows a common interface which is defined by abstract product. Concrete products implement the abstract product interfaces. In our example, we are designing a GUI system for multiple operating systems. The abstract factory GUI factory will define methods for creating buttons and checkboxes. These methods are not tied to any particular platform but ensure that the created components conform to the platform-specific design. The concrete factories such as Win Factory and Mac Factory implement the methods to create platform-specific components. For example, Win Factory creates Windows-specific buttons and checkboxes, while Mac Factory creates Mac-specific components. This decouples the client code from the concrete details of the products being created. The abstract products are the interfaces for the components like button and checkbox. These interfaces declare the common behavior for the components, such as the render method. Each concrete class will implement this method according to its specific platform. The concrete products are the platform-specific implementations of the components. For instance, Win button and Mac button are the concrete implementations of the button interface. Each class implements the render method to display the button according to its respective platform. The button interface declares the render method, which is implemented by each concrete button class. The render method allows the button to be displayed differently depending on the platform. By defining this method in the interface, we ensure that all buttons behave consistently across platforms. Similarly, the checkbox interface declares the render method, which is implemented by each specific checkbox class. This allows the system to handle different platform-specific checkboxes while maintaining a consistent interface. The GUI interface declares the methods for creating buttons and checkboxes. These methods are platform agnostic. It's up to the concrete factories to implement them and return platform-specific components. The Win button class implements the button interface for Windows, and its render method displays a Windows-specific button. By adhering to the interface, the class ensures that it behaves consistently with other buttons in the system. Similarly, the Mac button class implements the button interface for Mac, ensuring that the button behaves according to the Mac design guidelines. This makes it easy to swap between different platforms while maintaining consistent behavior. The Win Factory class is a concrete implementation of the GUI factory. It creates Windows-specific components by implementing the create button and create checkbox methods, ensuring that all components created by this factory are compatible with Windows. Similarly, the Mac Factory class creates Mac-specific components. It implements the create button and create checkbox methods to return Mac-specific products. This allows us to easily switch between different platforms by using the appropriate factory. The abstract factory pattern ensures that related products are created consistently and are compatible with each other. It isolates the concrete product classes, making it easier to switch between different families of products. The unified interface also simplifies the process of adding new products to the system. So what's the difference between the factory pattern and the abstract factory pattern? The factory pattern focuses on creating a single type of product, such as a document or a button. The abstract factory pattern, on the other hand, is used when we need to create families of related products, such as buttons and checkboxes, for a specific platform. We should use the factory pattern when we need to create objects of different types that share a common interface, and when object creation requires specific logic. We use the abstract factory pattern when we need to create families of related objects that must adhere to a set of interfaces and be compatible with each other. For today's exercise, design a furniture store system using both the factory and abstract factory patterns. Use the factory pattern to create individual furniture prices like chairs, tables, and sofas. Then use the abstract factory pattern to create families of furniture such as modern or classic furniture. Be sure to draw UML diagrams and implement that design. Today we explored the factory and abstract factory patterns, two essential tools for managing object creation in a flexible and maintainable way. By centralizing the logic for creating objects, these patterns make your system more scalable and easier to extend. Tomorrow we will dive into the singleton pattern, so stay tuned and thank you for your attention.